Very warm good morning, my dear students. Welcome to this digital chemistry class. Hope so you are fine and taking due care of yourself. Let's start as we have studied. We are starting our coordination compound chapter. So let's start in this basic slides. With the help of these slides, I'm going to tell you about coordination compound. So dear students, in coordination compound, basically the coordination compound is what? First slide is that. So in the coordination compound, it is those compound which is complex compound, and these are special class of compound in which the metal atom or metal ion are bound to a number of anion or neutral molecules. It means that there is a central metal which is bounded with so many neutral anion or neutral ion. Okay, in modern terminology these compound are called coordination compound. Nowadays it is called coordination compound, and coordination compound is also known as complex compound, so which are known as additional compound. Okay, so if you will see the diagram, this diagram, okay, so you can see there is a central metal which is red color and all the ligands which is of green color, and this red central metal of atom is surrounded by dative coordinated covalent compound. So that's why the compound name is called coordinate compound. Why? Because this bond is covalent bond. Okay, and the compounds are framed with covalent bonds, so that's why compound are known as covalent compound. Now if we need to differentiate on the basis of classify on the basis of nature, addition or molecule compound, these are divided into two categories. They are double salt and coordination or complex compound. It means that large compound are divided into two. Number one, salt, double salt. Number two, coordinate compound. So let's see the differences. First, double salt. These exist only in solid state and dissociate into constitution species in their solution. Whereas coordinate compound, they retain their identity in solid as well as in solution state also. Second, double salt, they lost their identity in dissolved state. Whereas coordinate compound, they do not lose their identity in dissolved state. Third, double salt, their properties are essentially the same as those of constituent species जिससे बने हुए वो. Third, their properties are different from these of their constituent. For example, if I say tetra potash, potassium 4 tetracyanoferrate, it doesn't show the test of iron 2 positive and cyano negative ion. Okay, so fourth difference is in double salt, the metal atom ion exists normal valency, whereas in coordination compound the number of negative ions or molecules surrounded the central metal is like metal item beyond its normal valency. So there are some of the examples of more salt is example of double salt, whereas you can see iron sulfate, ammonium sulfate, two salt is there, iron sulfate, ammonium sulfate plus 6H2. So dear student, day for yesterday in my video I sent you one video related to practical. That video was practical related to formation of crystal. So now this year you have the practical related to formation of double crystal. Okay, and hope so you started the work also. Then you can see there is one practical, that is to prepare a double salt crystal of more salt. Okay, so this is the, you can see the formula: iron sulfate, ammonium sulfate and 6 I can say hexahydrate. This I'm talking about this formula. So this formula is more salt and we are going to prepare it in our that chemistry practical. Okay, so again there are two types of complex compounds or big compound on the basis of nature, that is double salt and coordinate compound. We have already discussed the differentiation. Now next is double salt and coordinate compound. Some more information about double salt and coordinate compound. Example, an aqueous solution of potassium. Potassium is second double crystal which we are going to prepare. Will give the test of potassium, aluminum and sulfate. Okay, so formula potassium is K2SO4 dot Al2SO4 thrice 24 molecule of water. So which is giving after dissociation 2 K positive, 2 aluminum 3 positive, 4 molecule of sulfate and 24 molecule of water. It means that on the other hand side, coordination compounds are molecular compound that retain their identity even when dissolved in water. इसका कहने का मतलब हुआ कि व्हाट इज द डिफरेंस बिटवीन डबल सॉल्ट एंड कोऑर्डिनेट कंपाउंड. डबल सॉल्ट को अगर हम ब्रेक डाउन करेंगे तो उसमें जो आयन बनेंगे वो उसकी प्रॉपर्टीज जो है वो दैट प्रॉपर्टीज दैट विल not remain same. Okay, that will give the test of these. Whereas on the other hand side, when coordination compound are molecular compound, that will retain their identity even when dissolved in water. वो भी जो कोऑर्डिनेशन कंपाउंड है अगर वो उनको तोड़ देंगे या डिसॉल्व करेंगे वाटर में तो उसकी आइडेंटिटी सेम रहेगी. सो फॉर एग्जांपल व्हेन पोटेशियम फेरोसाइनाइड इज डिसॉल्व इन वाटर, इट डजंट गिव द यूजुअल टेस्ट ऑफ आयरन साइनाइड. अलग टेस्ट नहीं देता है, ये वही टेस्ट देगा जो पोटेशियम फेरोसाइनाइड का है. क्लियर? होप सो यू गॉट. सो इट मीन दैट दिस इज वन ऑफ द डिफरेंस. नाउ आफ्टर डबल सॉल्ट there is a complex compound, which is the name of the chapter. So complex compound is what? There is compound that have complex ion. एक वो compound जिनमें complex ion हो, बहुत ज़्यादा ion हो, and these are called complex compound. As a central metal ion in the complex ion, it form a dative or coordinate covalent bond. What is coordinate covalent bond? In which those ligand ion, negatively charged ion, these ions are sharing the number of electron, double lone pair of number of electron to these complex compound या central metal ion. Okay, once again, the central metal ion which is in complex present in the center. Here suppose this is central metal ion which is surrounded by these ligand, and these ligand are sharing one lone pair to the central metal ion. That is called coordinate bond. Okay, that is called coordinate bond, and complex ion are also known as coordinate ion because it is framed by coordinate bond, and hence corresponding compounds are known as coordinate compounds. So you got this slide. Next is one very important, or I can say very famous theory is there, which is on the basis of this coordination compound. So Alfred Werner Swiss, name is Alfred Werner Swiss. He was the chemist who put forward a theory to explain the formation of complex compound, in which उसने ये theory दी थी कैसे complex compound form होते हैं. In his postulate he will tell how complex compound is formed, so you need to listen carefully. It was the first successful explanation which became famous as the coordinate theory of complex compound. So the Werner theory is also known as coordinate theory of complex compound, which is also known as Werner theory. Okay, so dear students, first postulates of Werner theory, that was it is the central metal ion or ion which is metallic. Which metal? Transition element metal. Ion in coordinate compound exhibit two type of valency. Number one, primary valency and secondary valency. Whereas in double salt there is no two type of valency, there is one type of valency. So in coordinate compound there are two type of valency. This is the first postulate. ये सबसे पहली बात वार्नर थ्योरी ने कही कि जो भी मेटल सेंट्रल मेटल होगा वो दो तरीके की वैलेंसी से जो है वो सराउंडेड होगा, प्राइमरी एंड सेकेंडरी वैलेंसी. हियर यू कैन सी द टू वैलेंसीज आर देयर, NH3 एंड क्लोरीन. दो तरीके के लिगेंड है, NH3 एंड क्लोरीन. ओके, whereas primary valency are ionizable. So chlorine is ionizable here. You can see chlorine is ionizable here. It is chlorine negative charge. So primary valency is ionizable and correspond to the number of charges on the complex ion. And this is responsible for number of charges on complex ion. Primary valency apply equal well to simply salt and to complex and to satisfy the negative ion. Okay, so basically what is primary valency? It is number of oxidation state is equal to oxidation state, yeah, equal to 3 in this particular case. Okay, so you can see this picture. It is shown very well. Cobalt, this is the coordination compound of cobalt. If I will say NH3 3 bracket Cl3. Okay, this is the name, this is the formula of this compound, which structure is there, that we can learn later on also. So after this postulates, next postulate is secondary valency. Now primary valency is what? Which is ionizable, which is responsible for the number of charges on metal, which is number of oxidation number. Now what is secondary valency? It corresponds to the valency that a metal ion toward neutral molecule. Okay, ये वो valency है जो एक metal ion की neutral molecule की तरफ है, negatively charged की तरफ है, in the formation of its complex ion. So secondary valency are directional. Number one, as so a complex has a particular shape, so secondary valency is responsible for shape, primary valency is responsible for oxidation number. Okay, you can learn like this way also. The number of arrangement of ligand in the space determine the stoichiometry of the complex. Same thing is there, coordination number is equal to secondary valency, and secondary valency is equal to 6. So total how many molecules are there? You can see 1 2 3 1 2 3 4 5 6. So there are 6 NH3, there are 6NH3, as again I am telling the formula we will write like this way: cobalt NH3 6Cl3 whole bracket. Okay, so this is secondary valency, this is primary valency, this is primary valency, this is secondary valency. Secondary valency is responsible for shape, direction, complex structure. Primary valency is responsible for number of oxidation, number. So next is if we will see the in combined Warner theory, the postulate of the Warner theory is the postulates of Warner coordinate theory were actually based on experimental evidence rather than theoretically. He did experiment, then after that he has given these postulates. Second, although Warner theory successfully explained the bonding feature in coordination compound, but it has some drawbacks also. So first drawback is it doesn't explain why only certain element form coordination compound. क्यों सिर्फ कुछ एक एलिमेंट ही कोऑर्डिनेशन कंपाउंड फॉर्म करते हैं. सेकेंड, इट डजंट एक्सप्लेन व्हाई द बॉन्ड इन कोऑर्डिनेशन कंपाउंड हैव डायरेक्शनल प्रॉपर्टी. ये भी एक लिमिटेशन थी. ही वाज नॉट एबल टू टेल कि देयर इज डायरेक्शनल वैल्यू, बट ही वाज नॉट एबल टू टेल व्हाई. इट डजंट एक्सप्लेन द कलर. यस, वार्नर थ्योरी डजंट एक्सप्लेन द कलर ऑफ सॉल्ट, magnetic property of salt, optical property of salt. For that purpose we have one more theory, although that theory we will study in the last end of the chapter where we are talking about the bonding part, but I am giving introduction of that theory so that it should relate. So Warner theory basically help us to understand there is primary and secondary valency. Basically it help us to understand that the primary valency is for oxidation number, secondary valency is for shape, but why that he is not able to see. So Warner theory was not explaining color, he was not able to explain magnetic property, he was not explaining optical property. So what? Then one more new theory came, that is BBT and CFT. Two theories came, valence bond theory and crystal field theory. And dear students, once again याद रखो इन वर्ड को, valence bond theory and crystal field theory, because in the end of this chapter both these theory is coming. At that time I will ask you where we studied valence bond theory and about crystal field theory. Okay, so now after this Warner modern electronic theory, with the help of diagram, you can see the coordination sphere. If metal is 2 positive, their metal is 3 positive. So you can see one extra electron is there, and this is outer surface. And if there is metal 2 positive which is donating 1 electron to metal 3 positive, there one I can say conducting polymer is occurring in outermost surface. So it means that जब इलेक्ट्रॉन के अंदर, मेटल के अंदर का न्यूक्लियस से कोई इलेक्ट्रॉन या मेटल के एक स्फीयर का न्यूक्लियस एक इलेक्ट्रॉन शेयर कर रहा है बॉन्ड, या इलेक्ट्रॉन जो लिगेंड शेयर कर रहा है, तो उसके अंदर आउटर सरफेस एंड इनर सरफेस, इन बोथ द सरफेसेस देयर इज सम ब्रिजिंग विद द लिगेंड, formation of bond. Okay, now what is the basic application of Warner theory? First application of Warner theory is that suppose for cobalt 3 positive amine, which structure we studied for that, cobalt tetrachloride 6 amine, 3 AgCl, and it is giving 3 chloride ion, whereas 5 if 5 ammonia is there and 2 AgCl will bonded, then 2 chloride ion will be there. When there is 4 ammonia, 1 chloride ion will be there. When there is 3 ammonia, no chloride ion will be there, because number of chlorine is 3, number of ammonia is also 3. Remember, number of chlorine and number of ammonia is 3 minus 3, it is 0 chloride ion. Whereas 4 ammonia is there. See, once again I am telling, here's how many ammonia is there? 6 ammonia. Okay, when there is 6 ammonia, one minute dear students. Okay, when there is 6 ammonia, 3 chloride ion, 6 minus 3, 3, so 3 chloride ion is there. Whenever 5 ammonia is there, 3 chlorine is there. 5 minus 3, 2, then 2 chloride. Similar way, 4 minus 3, 1, then 3 minus 3, 0. So on heating with HCl at 373, cobalt amine doesn't evolve ammonia. This is the basic application. He is determining, this theory is determining the number of ion also. Primary valency of cobalt is 3 and secondary valency is 6. So secondary valency minus primary valency is the formula to determine the number of valency, negative ions. Okay, all the compound differ in their respective. Yes, this is different, this is different, this 6-1 is different, then 6-1 is different, 5-1 is different, 4-1 is different, and 3-1 is different. Okay, that is also one point. Next, Warner theory conclusion proposed putting all molecule and ion within the surface sphere in bracket and those free word use कर रहे हैं हम, anion that dissociate from the form the complex ion when dissolved in water outside the brackets. So you can see we can write that outside the brackets. Here some of the example. This is original formula where CO Cl3 6 NH3, but you can see later on the color is orange, 5 is purple, 4 is green, and 3 is violet. It means that as number of ion decrease, the color will also change. This is the first proved experiment. As number of ammonia amine decreased, color has changed. Free chloride ion will also decrease. So what is happening in the end? Modern formulation, the change is there in formation. The change is there in this formula. So that is because of this extra one. Okay, now some of the information should be there. Yesterday one more video I shared that is related to important term. These terms should be very much clear in your mind, then you can understand the chapter. Okay, so there was two terms very important, metal and ligand, because metal is surrounded by ligand. So what is ligand? Okay, the molecule or ion which are coordinated to the metal. Which metal? Central metal or ion is called ligand. It is the molecule or ion, या ligands are the molecules or ions which are coordinated मतलब जो बॉन्ड बना रहे हैं. कौन सा बॉन्ड? कोऑर्डिनेट बॉन्ड. किसके साथ? सेंट्रल मेटल एटम के साथ, आर नोन एज ligand. For example, K4 bracket, this bracket is the sign of coordination compound, hexacyanoferrate, whereas 6 cyanide group is there and it is coordinated with Fe2 positive, which is ligand. So cyanide is 6 cyanide is the ligand here. Ligand can be negatively ion, it can be positively ion, it can be neutral ion. Okay, and ligand are Lewis base, and central metal atom or ion is acid. Central metal ion is Lewis acid and the ligand are Lewis base. Okay, what is Lewis acid base? That you have studied in +1 class. So there are different types of ligands: monoligand, polyligand. Monoligand is unidentate, polyligand is multidentate. This also I have cleared in yesterday's video. Uni mean mono, yes, single, poly mean many. So there are third type of ligand, that is ambidentate. If a ligand has two or more donor atom, एक या दो से ज़्यादा डोनर एटम अगर किसी लिगेंड में हुए, the complex is formed only one donor atom is attached to the metal. For example, this is metal and nitro NO2 जिसको ऐसा खोल के लिखा हुआ है N double bond O nitrito not nitro N, which is yellow complex. Whereas if the metal is like this way, mean अब क्या difference है दोनों में देखेंगे ध्यान से. In the first case, metal is attached with nitrogen. In second case, metal is attached with nitrogen. But in first case, the nitrogen is attached with 2 oxygen directly. Whereas in second case, nitrogen is attached with 1 oxygen directly and other oxygen is attached with second oxygen. So it means that this is giving yellow color, this is giving red color. This is called nitrito N, this is called nitrito O then. Okay, this because of this, the ligands are different. So first, monodentate ligand. Monodentate or unidentate ligand is one donor atom, one point of attachment, and can coordinate with metal ion at one site. Chlorine, ammonia, water. Chlorine is negatively ion, ammonia is neutral, or water is also neutral. So for example, metal is this and oxygen is direct attached from H2O. That's why only oxygen is attaching. That is called monodentate. Whereas second type of ligand is polydentate or multidentate, where two or more donor atom or point are attachment. Polydentate ligand are further classified as bi, tri, hexadentate, वो डिपेंड करता है कितने. ऑक्सालेटो, इथाइल डायामीन which is EDT, डाया एस्टाइलो डाइक्सिन, डाइपाइरिडिल और एस्टाइलो एसिटोटोनेट. These are some example of polydentate. You can take the screenshot of this also. Okay, so next is coordinate compound number. Now what is coordination number? It is next important term. Coordination number is a number, okay, which is written. Coordination number is what? It is the number of ligand. If I will zoom it a little bit, it is the number of ligand. It is the number of ligand atom bonded directly to the central metal atom. कितने ligand direct central metal atom से attach है तो उसको हम coordinate number बोलते हैं. जैसे इसमें मैं 3 बना रहा हूँ तो 3 is the coordinate number. Okay, similar way. In this case, you can see how many coordination number is there? 6. Why? Because 6 ammonia is attaching to cobalt directly. Here 2 amine attached with silver. Here 3 ethylamine is attached with. So that's why these are 3 ligand, 2 ligand, 6 ligand, whereas coordination number is this. Okay, so geometry of complex related to coordination number. If coordination number 2, it is somewhere like structure that we have studied in hybridization. If coordination number 2, तो obviously linear structure. If 5, trigonal pyramidal. If 4, tetrahedral square planar. If 6, octahedral. So in balance bond theory, we will study only this and this. Coordination number 4 and coordination 6 is there in syllabus. Coordination 2 and 5 is not there. So you need to focus what is the structure of tetrahedral, what is structure of square planar, what is structure of octahedral. So you have seen. Now after this, complex ion, if you will say, to complex ion is what? These are the complex ion which has a metal ion at the center and number of other ions are surrounding by this. So this is very simple. Complex ion वो आयन होते हैं जिसको एक ब्रैकेट में लिखा जाता है, किस ब्रैकेट में, इस तरीके के ब्रैकेट में लिखा जाता है और ऊपर आयन लिखा जाता है. जैसे ये सपोज दिस इज 3 पॉजिटिव, 3 नेगेटिव, 2 पॉजिटिव, 2 पॉजिटिव. दीज आर कॉम्प्लेक्स ion. Okay, and it will be written outside the its that structure. Now next is coordinate entity. This we have already done. Coordinate entity is those metal atom or ion which is bonded to fixed number of ion or molecule is called coordinate entity. It can be written inside this bracket where first is metal, then primary valency, then secondary valency. Okay, which is fixed. Suppose cobalt is fixed with chlorine and ammonia, chlorine and amine. So both ion are coordinate entity. So these all three things, metal, center metal, primary valency, secondary valency, these are forming coordinate entity. Here coordination sphere. What is coordination sphere? This is whole set is called coordination sphere. Let me zoom it, then it can be more clear to us. So you can see here, dear students, this cobalt is called central metal. Here you need to understand this cobalt is central metal. This NH3 is ligand. Okay, this 6 is a coordination number. Okay, and this whole which is inside this bracket is called complex ion, and this is called oxidation number. These are called primary valency, and this whole set is called coordination compound, yeah, coordination sphere. This whole set is called coordination sphere or coordination compound. This is the special property of coordination compound कि like कैसे लिखते हैं इसको. जैसे मॉलिक्यूल लिखने का एक तरीका है, वैसे ही coordination compound लिखने का एक तरीका है. If suppose you will write NH3 in front of CO, if you write this 3 this side, if you write chlorine inside and ammonia outside, whole equation will be wrong. Whole coordination compound will be wrong. So you should know how we can write it. Yeah, what is the process of writing this? Okay. So there are some homoleptic. Homoleptic are what? Where one kind of donor group attached to metal ion or atom. एक ही तरह के donor group जब एक से ज़्यादा बार अटैच होते हैं तो उसको homoleptic बोलते हैं. ठीक है? This word use homoleptic. So for example here homoleptic, this is heteroleptic. Why? Because R1 is different than R or R, where all R is there. So this homo, this is hetero. This is asymmetry. Asymmetry means all three are different. Once again, homoleptic are what? One kind of donor group attached to metal. Like this is homoleptic because you can see here with product, this 1R, 2R, 3R, all three are here R1, different type of ligand is there. These are asymmetric because all R1, R2, R3 different. These are the example of homoleptic, heteroleptic and asymmetric. After this, charge number of complex ion. So how to calculate the charge number of complex ion? So these things we will do tomorrow. Coordination polyhedron, Silvic, effective atomic number. Then most important is nomenclature. So tomorrow's video I'm going to take the nomenclature. Hope so. All the definition, all the term, classification of coordination compound, Warner atomic theory, all these things you understood. And watch this video once again very carefully. Try to understand whatever I'm going to tell you, and watch this video 2 times, 3 times. After that, prepare your own video after watching this, and if still some problem is there, you can ask me. Okay, so thank you very much, and stay safe, stay healthy, because it is very important. Thank you. Have a nice day.